Hello and welcome to TidyX episode 4, A New Hope. My name's Ellis Hughes. I'm a statistical programmer at Fred Hutch Cancer Research Center.
And my name's Patrick Ward, and I do data analysis in sport. And this is the TidyX podcast, where we go over code submissions from Tidy Tuesday. If you have questions, feedback, comments, things that you might like to see explained, you can hit us up at tidy.explained@gmail.com, and that's explained spelled out as you would normally spell it.
All right, so this week's Tidy Tuesday data is on beer production.
Yes.
So I don't know about you, but I like beer a lot. So
yeah,
I was excited about this.
Yeah.
And there were some great submissions this week. I think a lot of people were pretty active, partially due to the topic, partially due to, we're all inside. But one that we saw this week was from Dr. Maggie Sogin, where she explores beer production, but she does it in a really interesting way. So she uses a cool package called Patchwork to stack these two plots together in a really, really informative way. And it's super simple. So we're really excited and really wanted to share that with you. Maggie shared her code here where it's on GitHub. And so we pulled that down and brought that into our studio session. Cool. So it's right here. This is the first TidyX where we've gone through and somebody actually started their formatting in R Markdown. So we were super excited about that. We really like that format. It makes it really easy to go through the code and it makes it really clear the organization of everything. So this is the beginning of the YAML. So she's calling it beer production. Then she has this first step here where it's RM list equals LS. And what this does is it clears out everything from your environment. So LS lists all the objects that exist, and then RM will remove all of it for you. You can see this a lot in some older code, but realistically, if you're working in an R Markdown, you don't really need to be worrying about clearing out your environment and setting up your workspace, because when you click this knit button here, it's going to run it in a new R session and in a completely separate one. So you don't have to worry about contamination. And just realistically, you should always be working in a new R environment. You can do that by going into session and do restart R there, or you can, as you can see, there's a shortcut Control-Shift F10. And so that'll just restart your R session, which will actually clear out your entire environment, including any loaded packages, which does not get done with the RM. All right, so then in this section here, Maggie is loading in the various libraries she's going to be using. So ggplot, tidyr, dplyr, these are the pretty standard tidyverse packages. She could have also done that with tidyverse. But then you're seeing some interesting new packages down here. Patchwork is a package that we're going to be highlighting in a little bit. Then there's lubridate, which is a package for handling date time objects, which can be rather complicated. Then there's these three packages down here that are new and actually extend ggplot too. hrbrthemes is a bunch of themes set up by a guy named, I believe his name's Bob Rudis, but you can find him on Twitter at hrbrmaster, so HRBRMSTR. And he is a great follow. I highly suggest everyone follow him. You'll learn a lot about R, and just by following a lot about InfoSec and everything like that. Then there's the Wes Anderson package that also has palettes that allows you to color things the way you want it. And then ggridges is a package that extends ggplot too, so you can do ridge plots, which we'll cover in a second. All right. So this first step here, she loads in the the data using read CSV from the long slug there. I would suggest using Tidy Tuesday R, but I'm a little bit biased towards that. So let's run those steps above. All right. So then she loads in the data and does a quick head just to look at what she's got here. So you can see data type. So what is the type that's being brought in, the material? You're just, basic information that she'd be needing to go through. And then she does a unique to see what are all the data types that exist. And in this case, it looks like it's only pounds of material used, which is, I think, what she wanted to be pulling in. Now she immediately hops into the first plot that she does, which is great to be doing that. Makes it she's doing all her processing right before she throws it into her ggplot, which will make it so you can iterate a lot more quickly through everything and make that clearer. So what she's doing here is she's creating this new field, year month, which is creating a date time from the year and the month fields there, and then she's subsetting down to only keep the year month type, which is the type of product being used in the beer, and then month current, which is the amount of product used that month. She then filters to remove the types that are not total used, total grain products, and total non-grain products. So she's removing these three from the data set because she doesn't care about that. She wants to know how much of the actual type is being used, not the totals. She then throws it into a ggplot2 and defines her aesthetics up here in the ggplot2. So she's saying my x-axis is the year month, my y-axis is month current, and the fill, so what color is type. So what is it malt and malt products, corn and corn products, and then throws it into a geom density where she defines a few extra things here. She defines her theme as theme classic, which takes it away from the normal ggplot themes and sets it to be a little bit different. And here's where you see her using the Wes Anderson package here. So what she's going through is she's setting the values of the colors to be based on, she's grabbing these two colors here, the Darjeeling 1 and Darjeeling 2. So let's quickly take a look at what's going on this far. Oh, I didn't get everything. All right, so this is a density plot. So this is summing together. All of this is going to add up to 1. And over time, you can see how much of the specific product is being used. So it can create this, really cool looking plot here where you can look at the proportions of everything as you go. And then the coloring, it looks really nice because you used the Wes palette from the Wes Anderson. By default, it'll use the ggplot base colors, which are rainbow, and it works, but but it's not as nice, right? And then she adds the extra labels there and sends this legend down to the very bottom. So let's run that entire chunk of code there. All right, there you go. So it looks super nice, and you're able to see the density, the proportions basically of the various type of product being used over time. And so there's a big drop here after 2016 of the use of sugar and syrups, it looks like, in your beer. So that might be good. That might be a little bit healthier.
Health conscious. Health conscious.
Yeah, exactly. Cool. So Patrick, do you want to explain this second plot here?
So the next plot, similar to above, she actually does all of her pre-processing within or just prior to the plot, all within one step. So as Ellis said, this is a great way to quickly iterate. It's one of the beauties of R, quickly iterate through these things. It looks like it's the same pre-processing steps. So there's a bit of a mutate to create that year-month variable. Then she's selecting the columns that she needs for her plot. She's filtering out the types that are the summated, the aggregates of each of those different products. And then she gets right into creating this cool ggplot, and she uses that geom density ridges function there. So these kinds of plots are really interesting. We actually use these a lot. Usually, for example, what you'll see is it's essentially like a histogram, or it essentially is a series of histograms for each of the types that she sets on the y-axis. So the y-axis is actually the group that you're looking at, and then the x-axis is the continuous variable that you're attempting to plot. In this case, that month current variable is the amount of product being used in each month for each type. So again, we use this a lot. Like if we only had two groups and we were trying to, let's say, compare differences between groups, we might plot a histogram of each of those groups overlaying each other so that we could get a sense for how big or how large the distributions differ from each other, or the means or the medians of those distributions. In this case, we have several different types. We have several different groups. And so if we were to, for example, histogram there. Yeah. So if you run that, you'll see how busy this is going to look if you were to run this over multiple groups like this.
You can only have a X or Y aesthetic. Interesting.
You'd have to remove the type. So remove Y equals type. Yep. Yeah. There we go. And then if you run it now, you'll be able to get this overlaying. Usually we'd set the alpha level so that it's kind of clear. We would do density instead of histogram though, because otherwise you'll get these stacked. So it should be density, and then if you run that,
I can type, and then alpha is equal to. So alpha sets how clear it is to see through the colors.
Yeah, correct. That's right.
Ooh.
So obviously we have one group that's extremely skewing the distribution, and you're kind of limited to it looks like the largest group. But we have all these. What is that? Like 7 or 8? Looks like maybe 9 or 10 different types. So the ridges plot is a really cool way to do this. So we get rid of that geom density and we put Y equals type back into the ggplot aesthetic. And you go ahead and run that, and we'll see this cool ridges plot that gives us a look at the distribution of each of those different types in a very simple way. There's all kinds of different styling you can do and arguments you can provide to the ggridges function. You get lines for the median. You could get lines to highlight certain quantiles. I think you could even use a rug function to put the actual slashes underneath where each of the points within that distribution lie. But this is a really cool way to just get a sense for the distributions you have when you're plotting large numbers of groups. So we use these all the time. Cool.
Yeah, so you can see, like with corn products here, there's a bit of a double hump here. Meanwhile, hops looks like it's following a much more standard distribution there. They're hops used as extracts.
Yeah.
Versus malt and malt products. There's a big chunk down here, but then there's a huge and very wide distribution.
And it looks like the sugar and syrups, rice and rice products, and the corn and corn products follow almost the exact same bimodal kind of distribution. So I wonder if those, I don't know anything about making beer, I just consume it, but I wonder if maybe those things are frequently used together in a, when you're making the products. I wonder if they're always used together, and that's why they follow similar distributions. Who knows? But cool plot. And then she's gonna patch it all together into one single page, as if maybe you were putting together a report for the brewmaster at your favorite brewery.
Mm-hmm. So Patchwork we haven't really touched on Patchwork yet, and this is because it's such an amazing package. You use it and you don't even realize how much it's doing, right? And so this part here is what Patchwork is doing for us, right? So what it's doing is we're telling it, okay, take plot 2 and put it above plot 1. All right, that's the syntax is just so simple. It makes it so clear the order in which you should be doing things. You can also like add things. So say for some reason I wanted to put the second plot down there again. This is the syntax. So you're saying, okay, put plot type 1 up top there, and then put these two next to each other. And you can just run it, and it's super clear, super understandable to read what the intent is. She's then saying here for the layout, she wants the plot that is on the top to be twice as tall as the plot on the bottom there. So it's a ratio of 2 to 1. And then immediately sending it into ggsave, where she's defining the height and width of the PDF that gets generated. So she wants it 5 inches tall by 8 inches wide, and saving it as a PDF. And so we'll just quickly run that, and it gets sent here. So we have the two plots that we had there with the legend down at the very bottom, because they follow the same coloring, and it just looks fantastic. I thought it was a super great way to show how Patchwork works, and then introduce some two new types of plots that we haven't covered yet. And there it exists, the PDF that we generated there. So hey, all right. So forgive my computer. Ooh. All right. So thank you, Maggie, for submitting this and letting us go and review or explain your code. It's fantastic, and now we'll get going on the data, or using Patchwork in a new way.
Yeah. So I was pretty excited to do this one just because Patchwork is a new package to me. Usually when I would create reports, if I was creating a report with multiple figures and visualizations or tables on one page, I'd use something like cowplot or like a grid arrange, which I think is from the, if I remember correctly, from the Grid Extra package, things like that. So I was excited to try out Patchwork, and also to do some stuff with some interactive graphics. So we built that all into this kind of markdown file today. So all of these packages that we're running up here up front, everything from last week where we built the Shiny app using the NBA data, that's going to take place in this single chunk here where we're doing all of our loading and pre-processing of the data so that we could jump right into generating the code that's going to produce our visuals and then ultimately produce the report once we knit this together. So we run all the packages. That's totally fine. All the stuff that we used last week with the inclusion of Patchwork. From the rvest package, we use read HTML, where we're going to get the link to the data, and we run that in. We run through. We pull the table that we're interested in, which has the totals for each player in the 2019 season, and we do a little bit of pre-processing to kind of clean things up. Take a look at the data at the top, and we're ready to go. So we've got all of our players in one single data frame now, and we're ready to do some visualization. So yeah, we can take a look at that there.
If you want more detailed explanations of how this all works, go watch our prior episode, episode 3, and we go in depth in explaining how each one of these steps works.
Yep, exactly. Okay, so into the data visualization. So I did a few visualizations so that we could plot them all on one page. I'll show you a static version and then the interactive version. So the static version here, I just looked for something to plot. I decided to plot the relationship between points influenced by minutes played. So I go through the ggplot, and I have minutes played on the x-axis, y-axis is points, and I actually label this by player. That's going to come into effect when we actually use the ggplotly function to make this interactive. All this other stuff is pretty typical ggplot stuff. So I use ggpoint. I color it by position group because maybe that influences the points that players score based on the minutes played. I do a bunch of styling there with the theme. So I make sure I set the size of the x and y axis. I make them bold. I set the size of the title and the subtitle, and I add in a nice little caption there at the bottom of the plot just to give reference to where the data came from, which is basketballreference.com. So if we go ahead and we run that, we're going to get a nice little plot here that shows a relationship between minutes played and points, colored by position group, reference at the bottom there in the little caption, and that looks pretty cool. Now remember, in the aesthetic up there, I had label equals player. So where that comes into play is if we scroll down, I turn this into an interactive plot by saying run ggplotly over the minute points plot, and I want to make sure that I'm going to highlight those players within this plot. So as you run that, boom, here we go. So now we have the same plot, but as you scroll over it, you'll see that we can drill down. So who's up in the upper right up there, right? Tobias Harris. If we, I think the top one right in the middle there is, James Harden. We can also use the little tooltip to highlight over a series of players. Maybe we want to highlight over a few guys in the middle there and take a look who's there. We could certainly do that. Double click pulls us right out of that. So it's a really cool interactive plot. In a second, I'm going to show you how you put that into one single HTML report that you could then send out to colleagues or people who need to see this kind of report. I can quickly make a nice little shooting 3-point shot position report. So again, similar to what we saw in Maggie's code, I do a little pre-processing up front. I just remove those 2 position groups right there because there was like 1 person in them, so that doesn't make for a nice looking box plot. I suppose I could have found who those players were and reclassified them into something else. I renamed the column, which was called 3PA, which is what was brought in from basketballreference.com. And then I make a little plot. I reorder based on the median of 3-point attempts. I create a box plot and I flip it on its side because it's sometimes a little bit easier to look at box plots like that. All the same theme and stylistic stuff and labels are right there. So if we run this plot, boom, and here we are. We look at a cool little box plot showing us 3-point attempts by position group. As you could imagine, the power forward, small forward guys and the small forward shooting guard guys tend to take the most 3-point attempts, and the centers and the center power forward position take the least. And then
even the players that are closest to the net there probably don't shoot a ton.
They don't shoot a ton of threes. Yeah, exactly. As you would assume. And then the final plot is just a little XY plot. So I did this with shooting guards, and I look at steals per minute and points per minute, which is kind of one of the main roles that shooting guards are there for, is to get the ball and shoot the ball. So again, a little bit of pre-processing there where I do some stuff with the minutes played. I say, give me the guys that are above the 25th quintile there. So I set that. I want only the shooting guards. And then I do some mutate work where I'm calculating out the per minute stats. And then I actually scale them so that I have them on a basically each player relative to the population mean and standard deviation. For the a little more explanation of why we did that, or why I did that, and how that works, if you go back to TidyX episode 3, where we go over our Shiny app, I actually go into the function of setting the z-score and those kinds of things in there. So after that pre-processing, I create this plot here, which again, I'm using that label equals player argument because I'm going to want that to come into play when I make this interactive. I have on the x-axis steals per minute, the standardized version of steals per minute, and on the y-axis, the standardized version of points per minute. I set an H line and a V line, so a horizontal line and a vertical line, both centered at 0. That's going to create sort of like this bullseye. And so what you want is guys that are really good at points per minute and guys that are really good at steals per minute. They're going to come out in the upper right quadrant. They're going to be the guys that have the higher standardized scores in both of those categories. Then I set my geom point right there. All the same theme information in terms of the size of the x-axis and y-axis and title and caption and all that stuff. We go ahead and we run this, and we take a look at it in a static fashion, and that's pretty cool. But it doesn't give us as much information as we might like, so we can turn this into an interactive with the ggplotly function again. And now we have a cool tooltip, just like before, where we can scroll over the guys. We can see Bradley Beal was in there, Jimmy Butler, some of the big-time players. Again, we can zoom in on maybe those 4 guys in the upper right there that we want to see, like, okay, who are these guys that we're looking at? We can get a more detailed look at who's up in there. Drew Holiday, Bradley Beal. We double-click, and that pulls us back out. Okay, so how do we pin this all together into one cool report? Well, all these steps will come out in the knitted package. What I might do is just actually, if I was turning this into a report, I might only show out, for example, if we wanted to make this static, we could run that code right there using Patchwork. You could see, so what did I do there? I had the first graph. If we scroll down to the code, we could see the first graph is there, and I want that graph on that figure on the left. And then I put that vertical bar, which says, give me the next figure on the right, and split those figures into an upper and a lower. And I didn't do anything with the plot size like we saw Maggie do. I just kind of left them as the default, but certainly we could have done that. But that's a pretty cool graph. And then I figured, well, why don't we use the interactive? So if we were going to send this out to maybe a decision maker or something like that, we can use these interactives. And all of a sudden now we get interactive plots all on one page. And all that stuff. And then same thing here, we can actually scroll over the bars and you get the information coming from your box plot in terms of your interquartile range and your any of the outliers and things like that. So if we go ahead and we knit all this, what we'll finish with is a cool report that kind of walks through everything we did. I hid all of the code in the report. So again, if I was maybe creating this to send out to someone, I might get rid of the iterative graphing processes and just put in maybe the last one at the bottom that makes it interactive. So we get a cool title, we get our name, who did the report, all that kind of stuff. These are each of my steps. You'll notice that there is no code. This is totally interactive. So if I was going to email this out to, let's say I emailed this as an HTML file to Ellis, he would open this. It would open right up in his browser, and he could actually do all of this stuff right there. He could highlight guys. He could highlight chunks of the area there. That's James Harden. Double click and brings him out. If we scroll down, we get our static 3-point shot. We get our static XY plot. We get the dynamic XY plot, and then again, we can put them all together if we wanted to create one single report. Here's the patchwork version, and then if we scroll down, we can get the cool looking, cool to play with interactive version, and that's using the subplot function from the Plotly package, which allows us to combine these interactive plots into one single figure. And so that's kind of the use of Plotly and the use of Patchwork and the use of Markdown to begin to create your own kind of unique reports that you might need for work or for your research group or for your students if you're doing stuff for students or something like that.
All right. Well, thank you, Patrick, for taking us through that. I think that was a great example of how you can now show how you can use Patchwork on different plots and different data sets and make it all work. And then this interactive bit, I think that's just so powerful that you can give the power to the people that you're sending this report to, that they don't have to keep on going back and go, oh, what's that point up there in the upper left there or in the upper right there. They can actually just play around with it themselves and zoom in if they're curious about something, and then continue to do their own research as they go. Thank you all for being here and listening to us explain some more Tidy Tuesday data. Once again, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward. You can find me at Twitter at OSPPatrick. And again, if there's questions, comments, thoughts, things that you'd like to see explained in somebody's code, feel free to email into us. We love the feedback. Tidy.explained, spelled out, explained, @gmail.com.
All right. Thank you and take care.